In this video, we look at examples of rules that do not define functions. So the key point is that a function must assign exactly one output to each input in the domain. So let's see some ways in which this might fail, and maybe looking at it, it might look like it's a function, or one could think that it might be a function just because it has a formula, but it's not going to be a function. So let's say we have f from the rational numbers to the integers defined by f of a over b is equal to a. So every rational number can be written as a fraction where a and b are integers with b different than 0. And so the idea is that you take that fraction and you output the number at the top of the fraction. Now the issue with this, and why this is not a function, is that different rational numbers will have, a rational number, or the same rational number, so a rational number will have different fractional representations. So for example, half is equal to 2/4, right? But if you do f of half, you will get 1, which is different than 2, right? 1 and 2 are not the same integer, and this is what you would get if you applied f to 2/4, right? So in this case, the same input gave 2 different values, and so this is not a function, right? So the rule is not well defined. This is not a function. Okay. Let's see another example. So suppose we have g from the real numbers to the real numbers such that g of x is equal to 1 over x minus 1. So you might have dealt with this in your calculus course. What's the issue here? X equal to 1, or more precisely, g of x not defined for x equal to 1. Or in other words, what is g of 1, right? So if you replace the x with a 1 here, you're dividing by 0, and that is not defined. There are ways of defining this to be infinite and so on, but it's not going to be over the real numbers. It'll be over something called the extended reals, which is the reals with an extra symbol. This here is the real numbers, and so there is no real number such that it's written as a fraction with 1 over 0, right? So this is not a function. This is not defined. There is an element 1 that is in the domain, but it's not assigned any output. There's no number in the codomain that this number 1 gets assigned to. Okay. And another example, let's say, consider this function here. So let's do again from real numbers to real numbers, given by h of x equal to square root of x. And this you might have also encountered. What happens here if x is smaller than 0, right? So for example, x equal to minus 1. So when that happens, square root of minus 1 is not a real number, right? There are ways of defining that, and you'll work over the complex numbers or so on, but as it is here, square root of minus 1 is not a real number, which means that there exist at least, so it's going to be for all the negative numbers, but there exists at least one element in the domain, so one element that you input, and there's no output for it. And so this cannot be a function. And so what is the lesson here? The lesson is that formulas are not enough by themselves. To define a function, the rule, right, the formula, the rule that you're using, must be what's called well-defined. What that means is that every input in the domain must produce exactly one output in the codomain.